So let's start with problems on uniform circular motion. Okay, the first problem goes like this. A car of mass 2000 kg is running with a speed of 10 meter per second on a horizontal circular turn of radius 20 meter. What should be the coefficient of friction between the road and the tires so that the car may cross the turn without slipping? Take the value of g to be 10 meter per second square. Okay, now this is the question. Now remember the formula whatever we had. See, there is no banking of the road, correct? Since there is no banking of the road is straight. So we're not going to use any complicated formula. The formula for this was V is equal to root of mu rg. Remember? Okay, now what are the information that is given to you? Mass is given to be 2000 kg. Velocity is given to be 10 meter per second. And r value is given to be 20 meter. And g is given to be 10 meter per second square. Now the formula was, again I am repeating, V is equal to mu square root of mu rg. Correct? So do square on both the sides. You get V square is equal to mu rg. Now substitute the values. So V square, that's 10 square becomes 100 is equal to mu into 20 into 10. Correct? So 100 is equal to mu into 200. So mu is equal to 0.5. So basically the coefficient of friction has to be 0.5 between the road and the tire so that the car cannot slide and fall or skid or whatever. Understood, right? So the next problem is, so Earth revolves around the Sun with a speed of 30 km per second. What is the radial acceleration of Earth directed towards the Sun? Now given in this, 1 year is equal to 3.16 into 10 to the power of 7 seconds. Okay. Now what are the information given in the question? First thing, they have given the speed of Earth around the Sun, that is given to be 30 km per second. Correct? And what else is given? The time is given. So 1 year is equal to whatever value. Now if you look at this, see there is a given figure. This is the Sun, orbit of the Earth, and then 30 km per second is the velocity, correct? Now V is given to be 30 km per second, right? Now the distance covered by the Earth on the orbit, basically that's the circumference of the, you can say a circle, right? If you are taking the orbit as a circle. So circumference. Now what's the formula for circumference? 2 pi r. So 2 pi r is the distance travelled by the Earth, right? So 2 pi r is equal to V into T, correct? V into T. So 2 pi r is equal to, now convert the velocity given into SI unit. It's 30 km per second. So that will be 30 into 10 to the power of 3, correct? So 30 into 10 power 3 into, what is the time given? 3.16 into 10 to the power of 7. Correct? Now, if you multiply those two, you will get this as 9.48 into 10 to the power of 11 meters. So, 2 pi r is 9.48 into 10 power 11. So, r is equal to 9.48 by 2 pi into 10 power 11, which gives us 1.508 into 10 to the power of 11 meters. So this basically is the radius of the Earth's orbit. Okay. So 1.508 into 10 power 11 meters. Now we got the value of r. But what are they asking? They're asking the acceleration value, correct? So if you apply the same r value in the formula, a is equal to v square by r, you'll get this as 30 into 10 power 3 whole square divided by 1.508 into 10 to the power of 11, correct? So, see, the numerator becomes 9 into 10 to the power of 8 divided by 1.508 into 10 to the power of 11. So, if you divide that, you will get A is equal to 5.96 into 10 to the power of minus 3 meter per second square. Okay, this is the acceleration of Earth around the Sun. So that's 5.96 into 10 power minus 3 meter per second square. Understood? So this is another type of formula. So in the next video, you will see one more type of formula, one more type of problem.